for this one. So tutorial for the gas power cycle sector 3. Okay, so this question is taken from December 2019. Okay, so now the first question, just now you can answer, you can refer to my notes. Okay, this for advantages of the gas turbine engine. So this one is apparently in the note. So question B, we go focus on the question B only. So question B, okay, so question B, so start your calculation with the TS diagram. So TS diagram first. Okay, so the TS diagram. So it's going to be the pressure curve. Okay, right. So 1, 2, 3, 4. So they have the isentropic efficiency, right? 85% for both. So this one is going to be 2A lah, right? The actual T2S. Then this one is going to be the 4 actual, and one is 4S. And then they have the state of regeneration. So this one is going to be your T5 prime. And then they also have the value of T5. Okay, right. So in this question, they give you the value of the minimum and maximum temperature, which is, in this case is, this one is 3. Okay, so T1, so T1 is 300 Kelvin. And then the value of T3, the maximum, is 1200 Kelvin. See guys, And then they also give you the value of pressure ratio, RP. So RP equals to 8. Equal to P2 over P1. Okay. So beside RP, this also gives you the isentropic efficiency for the compressor and turbine. So that means kat sini we have the isentropic efficiency for the compressor 85%, as well as the isentropic efficiency for the turbine 85% also. Okay, right. And then the question you give also the value of the mass flow rate. So the mass flow rate actually is 100 kilogram per second. Okay, right. And then the air leaves the regenerator at the temperature of 700 Kelvin. So we have T5. Okay, 700 Kelvin. Okay, clear? So you got all the properties. Okay, then you have to proceed state by state. Okay, start with state 1. State 1, they have the value of T1, so there's no problem. So T1 is equal to 300 Kelvin. So there will be no problem lah. Okay. Okay, you can proceed to state 2 lah. Okay, state 2 is a process of isentropic compression. Okay. So you can make, that means you can use the isentropic relationship, which is T2S divided by T1 equal to P2 over P1. K minus 1 divided by K. This one also is equal to RP K minus 1 divided by K. So T2S can be found by, so T1 is 300 Kelvin. RP is equal to 8. Okay. And then this one is 1.4 minus 1 divided by 1.4. Okay. So can you calculate for me the value of T2S? Okay. So by using the isentropic relationship, you can find the value of T2S. Okay. So okay. I'm also calculate. So based on my calculation, the value of T2S will be 543.4342. Okay, 543.4342. Okay, so here is, okay, so 543.4342 Kelvin. So please check. Please check. Please check. Okay. Right. Okay. So yes. Okay. So right. Okay. And then so since you know the value of T2S, you can find the value of T2 actual lah. So by using isentropic efficiency for the compressor. Which is, this one is W compressor ideal divided by W compressor actual. Which is, in this case, is M dot Cp T2S minus T1 divided by M dot Cp T2 actual minus T1. So here can be cancelled. So you put the values. So isentropic efficiency for the compressor is 0.85. Is equal to T2S is 543.4342 minus T1. So T1 is 300 Kelvin. Divide by the T2 actual minus 300 Kelvin. So from here, you will find the value of T2 actual, right? Okay. So you will find the value of T2 actual. Okay. 0.85. Okay, so based on my calculation, you will find the value of the T2 actual will be 586.3932. So 586.3932. Okay. Okay, 586.3932. Kelvin, not a second. Okay, so please check. Okay, so please check the values. Okay. Okay, right. Okay, guys. Okay, and now you settle for the state 2. Okay, then you can proceed to calculate at the state 3. So state 3 is a process of the constant pressure heat addition. Okay. So the value of T3 is given in the equation, which is 1200 Kelvin. Okay. So there will be okay. And then you go for the state 4. Okay. State 4 is a process of the isentropic expansion. Okay. So isentropic expansion, that means you can use the isentropic relationship in order to find the value of T4S. So T3 over T4S equal to P3 over P4 K minus 1 divided by K. This one actually is also equal to P2 over P1. Right. And this one is RP K minus 1 divided by K. So the value of T4S is equal to T3. So T3 is 1200 Kelvin. Divide by the RP. So RP is equal to 8. 1.4 minus 1 divided by 1.4. So from here, okay, from here you will get the value of T4S. So T4S 1200, pressure ratio 8, and then you will get the value of T4S is 662.4537. If I'm not mistaken. So 662.4537. Okay, guys. So you get the value of this one. Okay, so T4S will be 662. 662.4537. Then you also can proceed to calculate the T4 actual by using the formulation of isentropic efficiency for the turbine. Which in this case is W turbine actual divided by W turbine Isentropic. We have this by is m dot Cp, T3 minus T4 actual, divided by m dot Cp, T3 minus T4 S added. So this one can be cancelled. So you get the isentropic efficiency in terms of the temperature. So you apply the values. So 0.85 equal to T3. So T3 is 1200 Kelvin minus T4 actual. So this is parameter you want to calculate. Then divide by the 1200 minus T4S. So T4S is 662.4537. So eventually, okay, you will get the value of T4 actual will be 743, 743.0857. 743.0857. Okay, so here is 743. Sorry, I forget. 743. 0857. Okay, 0857. So you have 0857. So here, okay, 0857 Kelvin. Okay, guys. So you complete for the state 1, state 2, state 3, and state 4. So since this is a regenerative case, so that means you have another state which is state 5. Okay, so for the state 5, okay, it's a regeneration case. Okay, we see kat sini we have T5 prime. Okay, so T5 prime is equal to T4 actual in this case, which is 743.0857 Kelvin. Okay, guys, and then you can also calculate the value of T5. Doesn't have to calculate because T5 is given, which is 700 Kelvin. Okay, guys. So, okay, you find all the properties. Then now you can start answering the question. Okay, so the first question, they want you to calculate the value of the backwork ratio. Backwork ratio is simply W compressor divided by dW turbine. Okay, so W compressor basically is equal to m dot Cp T2 actual minus T1. So the mass flow rate is given, so 100 kilogram per second. So put in the values. Cp is 1.005. So T2 actual is equal to 586. Okay, 0.3932 minus T1. So T1 is equal to 300 Kelvin. Okay, right. So based on this, you will get the value of W compressor. Okay, right. So you will get it. Okay, it's quite large. You get 28782.51. So you can get you can approximately say that 28.782 kilowatt. 28.782. Okay, 28.782. So 28.782. It's not kilowatt, it's already kilo, so that means it's megawatt. Right. Okay, megawatt. Okay, so you get the value of W compressor 28.782 megawatt, because you get 28,782 kilowatt. So this is a megawatt. Right, okay. Okay, if okay, then we proceed to calculate W turbine. Okay, we can proceed to calculate W turbine. So go for the W turbine. W turbine is M dot Cp T3 minus T4 actual. So here is 100. Cp is constant 1.005. So T3 is 1200. T4 actual is 743.0857. 743. Wait. 743 point. Okay. So 743.0857. 0857. Right? So based on this, you will get the value of W turbine. You will get the W turbine. Okay, let me calculate. W turbine. Okay, is equal to 45.919. 45.919. 45.919. Okay, so 45.919 megawatt. Okay, guys. Correct? And then, backward ratio, we'll just divide the W compressor, which is W compressor is 28782. Okay, 28782 divided by 45.919. The backward ratio here actually is equal to 0.627. Backward ratio 0.627. Okay. Okay. 0.627. Okay. Right. Okay. 0.627. So you answer the first question. All right. The second question is require you to calculate request you to calculate cycle thermal efficiency. Cycle thermal efficiency actually is equal to thermal efficiency is W net over Q in. W net over Q in. So W net actually is W turbine minus W compressor. This case is W turbine is 45.919 minus W compressor is 28.782. 28.782. So from here, the value of the W net is equal to 17.137. 17.137. 17.137. Okay. 17.137. Okay. 17.137. Yeah, okay. 17.137 megawatt. Right. Okay. And then you proceed to calculate Q in. So Q in is M dot Cp T3 minus T5. Okay. When you have the regeneration, that means T3 minus T5. If you doesn't have the regeneration, that means T5 minus T2 actual. Okay, right. So here, so we have here mass flow rate is 100 kilopascal, 100 kilogram per second, sorry. Cp is 1.005. So T3 actually is equal to 1200. T5 is given, T5 is 700. Right, so T5 is given 700. So from here, you can get the value of the Q in, okay. So let me check the value of Q in. In this case, this doesn't give you this one. So here is 700. T5 over this one. So Q in is hang on, let's do it 100. So here is okay, and by the 100. Okay, so we have 50.25 megawatt, 50.25 megawatt. Okay, 50.25 megawatts. Okay, so here is 50.25 megawatt. So from here you can get the value of thermal efficiency. Thermal efficiency will be 171137 divide 50.25. The thermal efficiency in this case will be efficiency is this one okay, so we had 0.341. So you will get the thermal efficiency is 0.341. Okay, 0.341. Okay guys, okay, right. So now we enter for the last question. So number 3, they want to calculate the value of effectiveness of regeneration. The formula for effectiveness for regeneration basically is equal to Q regeneration actual divide Q regeneration maximum. In this case is m dot Cp T5 minus T2 actual divide by the T5 prime minus T2 actual. So this one can be cancelled. So from here T5 is already calculated. So T5 is equal to 700 Kelvin. Sorry, it's not calculated. It's given 700 Kelvin minus T2 actual. So T2 actual actually is equal to 586.3932. 586.3932 divided by T5 prime. T5 prime is equal to T4 actual. So T5 prime actually is equal to this one, 743.0857. 743.0857 minus 586.3932. So from here you will get the value of Q regen. So from here you get the value of Q regeneration. So let me check the value of Q generation. Okay, so Q generation actually is equal to T5 minus T2 actual divide by the T5 prime minus T2 actual. So the value is, if it's estimate, is 0.725. 0.725. 0.725. 0.725. So 72.5%. Okay. Alright guys. So you got the full mark. As long as you got the question A full mark, then the 15 mark for the question B has been presented here. Okay, so you can take a look. Okay, so please check the answer. Okay, because I just make a quick calculation. So yes, okay. So is there any problem for this question? I think it's quite direct. It's quite direct. So I hope that this semester also this kind of problem will become out. So okay. So it's quite direct. So since they give you the value of the mass flow rate, then please use the mass flow rate. And then make sure you understand the information given. As you can see here, the minimum and maximum. So the minimum will be T1 and the maximum will be T3. So if you confused about the T minimum and T maximum, so please draw the TS diagram. So from the TS diagram, you will know which one is minimum, okay, and which one will be the maximum. Okay, so automatically you know that T3 and T1. And then students normally make mistake in terms of this one. Okay, they don't know the value of 700 Kelvin ni which temperature. So there will be another problem, right? But in this case, I actually said that. So the 700 is going to be your T5 and T1, right? So from that ratio, you can find the value of effectiveness. Okay, if anything okay, then we proceed to another question. Okay, so this question is taken from June 2019. So June 2019. Okay, so describe the working principle of an open cycle of gas turbine engine. So this one can be described by the schematic diagram. Okay, you draw the compressor, you draw the turbine, and you draw the combustion chamber, and then you describe the process from 1 to 2, 2 to 3, 3 to 4. Okay, so maybe you can say that 1 to 1 is a process of isentropic compression. Process 2 to 3 is a process of constant pressure heat addition, and 3 to 4 is process of isentropic expansion. So maybe you can get marks for this one, but in order to attempt the full mark of 5, you have to describe this process. Okay, so the process basically starting with the air is entering the compressor, right? And then the air will be increased, the pressure of the air will be increased in the compressor, and then this compressed air will be channeled into the combustion chamber. In the combustion chamber, the fuel will be injected into the compressed air. The combustion will be occurred. Okay, the temperature getting rises, and after that, it go for the turbine, and then this energy will be expand into the turbine, and the turbine will be rotate and will be rotate for the we drive the compressor at the front. Okay, that's a working principle. So with this, actually you get a 5 marks. Okay, so this one, the answer actually is already in your notes. So you please refer to the notes. Right, and then you go for the question B. Question B. So a gas turbine power plant operates on the simple Brayton cycle between the minimum and maximum temperature of 27 degrees Celsius and 7 to 7 degrees Celsius. Again, they use the term of minimum and maximum. So that means definitely you know that the minimum 37 is belong to T1 and the maximum temperature 7 to 7 degrees Celsius is belong to T3. During the operation of the cycle, the net power developed is measured experimentally to be 50 megawatt. So that means this one is the net power developed. That means the W net. They give you W net. 50 megawatt. The pressure of air at the exit of compressor is 10 times than the compressor index. So what it means? That means you know that the pressure at the exit of the compressor is P2, pressure at the inlet, the ratio between P2 and P1 is equal to 10. Basically, they give you information about the pressure ratio. And then both the compressor and turbine have the isentropic efficiency of 85%. So you have to sketch the TS diagram, and then based on the cycle, and then you have to determine the air temperature at the exit of the compressor and turbine, and then the work consumed by the compressor, the work produced by the turbine, and then the thermal efficiency, how many percent, and the mass flow rate of the air through the cycle. Okay, so they give you the value of Cp 1.005, and then Cv is not used in this gas turbine, and then the value of K, of course, 1.4. Okay, right. So you can start the answer the question. So draw the TS diagram first. Okay. So TS diagram. So TS diagram. So this is a temperature curve, right? So 1, 2, 3, 4. So since this you have the isentropic efficiency for both compressor and turbine, so we have the T2 actual, so T2S, and here is 4 actual and 4S. And then they have the region, rule implication. Okay, this doesn't have the regeneration. Okay, so this is only actual cycle, so it's quite simple, So they doesn't have the regeneration because the question doesn't state about regeneration case. So that means it's purely actual cycle of the gas turbine engine. So they give you the value of T1. T1 is 27 degrees Celsius, which is in this case 273 is 300 Kelvin. Okay, right. And then they give you the value of T maximum is 727 degrees Celsius. So when you added with the we added with the 173, okay, there will be 900 Kelvin. Okay, right? Okay, right? Sorry, 1000 Kelvin. Sorry, 1000 Kelvin. 1000 Kelvin. Okay. 1000 Kelvin. This one is 1000 Kelvin. Sorry. That is 1000 Kelvin. Okay, 1000 Kelvin. Okay, 1000 Kelvin here. Okay, so 1000 Kelvin. Okay, 1000 Kelvin. And then they give you also the value of the P2, okay, is equal to 10 times P1. Basically, is P2 over P1 equal to 10. So this one is going to be your pressure ratio. And then they also give you the value of isentropic efficiency for the compressor and turbine, which is 85%, right? Turbine is 85%, as well as isentropic efficiency for the compressor, which is 85%. Okay, and then they also give you the values of the W net. W net is given by 50 megawatt. So that's the parameter. Safe. So we have this one. So 50 megawatt. So the net power developed. So 50 megawatt. Okay, guys. Okay. So you've finished for this the information of the diagram. And then like I said, so please find the parameters or the properties of each state. Start with state 1. Okay. So state 1. So T1 is given, which is 300 Kelvin. Okay, alright. And then you go for the state 2. It's a process of isentropic compression. Okay. So you can use the isentropic relationship in order to find the value of T2S. T2S P2 over P1, K minus 1 divided by K. This one is RP. K minus 1 divided by K. So T2S is T1 300 times by 10, 1.4 minus 1 divided by 1.4. Okay. So from here, the value of T2S will be, let me check. Okay. 100 So, no. And we will get the value of the T2S is equal to 579. 579 point 579.2093. 579.2093. 579.2093. Okay, so you have here 579.2093 Kelvin. Okay guys, and then you have to find the value of T2 actual also lah. So you have to find the value of T2 actual. So use the isentropic efficiency for the compressor, which is in this case is W compressor ideal divided by W compressor actual. So here is M dot Cp T2A minus T2S minus T1 divide by the M dot Cp T2 actual minus T1. So this one can be cancelled. Okay, and then you put the value, so 0.85 equal to T2S, so 579.2093 minus T1 is 300 Kelvin, divide by the T2 actual minus 300. So from here, you will get the value of T2 actual. So T2 actual, in this case, you will get T2 actual is around 628, 628.4816. 628.4816. Okay, right? 628.48. Sorry. 4816. Okay. Right, okay. So please check the answer. Okay. I'm afraid I'm wrong. Okay. Right. So I want okay. So you solve for the T2 actual. And now you can proceed to go for the state 3. And you go for the state 3. Okay. To go for the state 3. State 3 is a isentropic expansion. Okay. Constant pressure heat addition. So they give you the value of T3. So T3 is equal to 1000 Kelvin. Okay. Right. And then you can proceed to calculate the value at the state 4. So state 4 basically is equal to isentropic expansion. So isentropic expansion, you can use isentropic relationship, which is T3 over T4S equal to P3 over P2. K minus 1 divided by K. 1 is P2 over P1. K minus 1 divided by K. 1 is RP. K minus 1 divided by K. Right? So the value of T4S can be found by using this formulation. So T3 is equal to 1000 Kelvin. And then RP actually is equal to 10. 1.4 minus 1 divided by 1.4. So from here, you will get the value of T4S. So let me check. So T4S, this one is 1000. Okay, the pressure ratio is 0.1. So the value of T4S will be 517.9475. So 517.9475. 0.9475. Okay. Okay, you get 517. Okay, 517. We have here is 517.9574. Okay, right. 517.9574. Okay, 9475. Okay, 9475. Okay, right. So sorry, some mistake here. There will be 517.973. 973. 1 9475. 9475. 9475. Okay guys, 9475, sorry. So 9475. 9475. Okay. Right. And then you can proceed to calculate isentropic efficiency for the turbine. Sorry, the P4 actual, the P4 actual. So here, basically, equal to W turbine actual divided by W turbine ideal. So here is M dot Cp T3 minus T4 actual divide by M dot Cp T3 minus T4 S. So this one can be cancelled out. So they will give you in terms of the temperature. So isentropic efficiency for the turbine is 0.85. And then the value of T3 is given by 1000 Kelvin, okay, minus T4 actual, okay, divided by 1000 minus T4S. So T4S actually is equal to 517.9475. Okay. So from here, you will get the value of T4 actual. So let me check the value of T4 actual. So T4 actual, we have 590.2553. Okay. Okay, 590.2553 Kelvin. Okay guys, we got all the properties. Okay, let me check the values again. 590.2553. Okay, alright. Okay guys, so you have completed all the parameters in each state. Okay, you go for the state. So you go for the first question. The first question requires you to calculate the temperature at the exit of the compressor and turbine. So basically, they want you to calculate T2 actual, which is 628.4816 Kelvin. So this one, T2 actual. And then T4 actual. So T4 actual, we have 590.2553 Kelvin. Okay, right. And then question number 2. They want you to calculate the work consumed by the compressor. So you have to calculate the W compressor. W compressor is equal to M dot Cp T2 actual minus T1. They have give you the value of W net. Okay, they have the value of W net. So from this W net, basically, they want you to gain the value of the mass flow rate. Okay, they want you to calculate the value of the mass flow rate. Okay, but in order to find the value of mass flow rate, first you have to calculate. You have to calculate the W compressor and W turbine by put aside the mass flow rate first, and then you will find the value of the mass flow rate, and then you recalculate the value of W compressor and W turbine. That's why in the question, the work consumed by the compressor in kilojoule per kg. Also, it's not necessary to find the value of mass flow rate. So since the question just want you to calculate in terms of kilojoule per kg, so you just proceed. Cp dt Cp over delta T. So this one is Cp T2 actual minus T1. So you put the Cp value is 1.005. So T2 actual is 628.4816 minus T1. So T1 is 300 Kelvin. Okay. So you can answer the question by kilojoule per kg because this is required by the question. Okay. Right. So let me check. So W compressor, we have 628.4816, okay, and 300 Kelvin. So you have this is 330.124. Okay, 330.124. 330.124 kilojoule per kg as per request by the question. Okay, right. So you settle for the W compressor, and now you can move to W turbine. W turbine, so question number 3 is they want W turbine. W turbine is M dot Cp T3 minus T4 actual. So this one is Cp T3 minus T4 actual. Then put the values. Cp is 1.005. T3 is 1000 Kelvin, and T4 you already calculate the T4. So T4 actually is equal to 590.2553. 590.2553. Okay, so based on this one, okay, you will find the value of W turbine actually is equal to 411.7934. 411. So 411.7934. 411.7934. Okay. 411.9734. Okay. Let me check the question, the answer. 7934. Okay. Sorry, 7934. 7934. Okay. 7934. 411.7934 kilojoule per kg. This is the answer. Okay. The fourth question, it requires you to calculate the value of the thermal efficiency. So thermal efficiency you can calculate by using the formulation for thermal efficiency is W net over Q in. In this case, W net actually is equal to W turbine minus W compressor. So W turbine is 411.7934 minus W compressor. So W compressor is 330.125. 330.125. Okay. 124. So yeah. 124. So from here you can get the value of W net. Okay. So let me check the values. So W net will give you 81.67. 81.6694. 81.6694. Okay. right? So 81. Okay. Alright guys. And then the value of Q in, you have to calculate the value of Q in. Okay. So m dot Cp T3 minus T2 actual lah. So here is Cp T3 minus T2 actual. So apply the values 1.005. So T3 is equal to 1000 minus T2 actual. So T2 actual is 628.4816. 628.4816. 628.4816. So from here, you will get the value of Q in actually is equal to Q in is equal to 373.376. Okay, right. Okay. 373.376 kilojoule per kg. Right. And then you can proceed to calculate thermal efficiency 81.6694 divide 373.376. So from here, the value of thermal efficiency actually is equal to 0.219. 0.219. Okay guys. 219. And then the last question is request you to calculate the mass flow rate. Okay, the mass flow rate of air through the cycle. The mass flow rate. Okay, number 5. On number 5, the mass flow rate. So basically, you got the W net is 81.6694 kilojoule per kg. Given the value of W net is 50 megawatt. Okay, given. So basically, the mass flow rate, this one for unit mass, so W net equal to W net in megawatt divided by W net in kilojoule per kg. Then you find the value of mass flow rate. So 50 megawatt is 50 mega. So can give into this one. Okay. And then this one is 81. 1.6794. Why you just find by 3? Because in this one is in kilowatt. This one is in kilojoule. Okay. And so it's kilo. So you maintain in kilo. So from here you can find the value of the mass flow rate. Okay. From here you can find the value of the mass flow rate. So let me check the answer. Okay, 50,000. Okay, so 50,000. Then the value of W net actually is 81 here. Okay, so 50,000 divided by 81. So the mass flow rate is 612.22. Quite large, 612.22. Okay, 612.22. Okay, guys. Okay, right. So you answered all the questions. Okay. So I hope you understand. Okay, so far in this one. Okay, right. Okay. So this some of the tutorial. Okay, maybe useful for you. Okay. For this topic lah. Okay.